Why you always lose. Imagine you're constantly in a lucky draw but always end up losing, and in the end you can only go home sad. This video will help you avoid those pitfalls and let you return home happily. Before we begin, I hope you to hit the like and subscribe buttons for this video. Wishing you good luck. Assuming you start with $100 and then undergo multiple operations. In each operation, there's a 50% chance of increasing by 10% and a 50% chance of decreasing by 10%. Indeed, at first glance, it may seem like a break-even scenario due to the equal probabilities of gaining and losing. But in reality, it's not the case. Let's take a closer look. The first time, we have only two options, one is to increase, and the other is to decrease. Then the chart will display all outcomes. You can see clearly that their outcomes are 110 and 90. The average of this round is the total of both divided by 2, which is 100. This seems fine, right? You start with 100, and on average, you end up with 100. But this is only the first round. Let's continue and see what happens next round. In the second round, there will be 4 different outcomes. After calculation, their average is also 100. What I need you to pay attention to are those 299. They both have a 50% chance of occurring. At a 50% chance, you'll on average gain 99. This means that within that 50%, you're also losing what you initially had. We divide them into 2 groups. On the left side, you can gain, and on the right side, you'll experience a decrease. Ultimately, we can see that there's a 25% chance of increase, leaving 75% for decrease. So, we have a higher probability of losing. This sounds absurd. Let's first take a look at what happens with more rounds. In round 3, there are 8 outcomes. I will quickly analyze them and show you. We have a larger portion of 75%, with an average of 99. The difference lies in their distribution. Now, only 12.5% can increase. Although the average remains 99, we can see that the likelihood of increase decreases with each round, while the likelihood of decrease increases. This implies that in more rounds, we are more likely to lose. Do you know why this happens? What secret is hidden in it? Going back to the previous events, if now I get an increase the first time, followed by a decrease the second time, and then continue in the same alternating pattern, the probabilities for this series of events seem fairly balanced. Now let's take a look at the value after each occurrence. The observant ones among you should quickly notice that with each increase in the number of occurrences, it keeps decreasing. Its trend line is gradually declining. We can calculate it like this. Multiplying 110% by 90% equals 99%. It means you can only retain 99% of the original amount, resulting in a loss of 1%. This is why you always lose. I've explained it to you mathematically. So how do we know if we'll gain or lose? In the previous scenario, the result was less than 1, so he lost. If it's greater than 1, he'll gain. Finally, if it's equal to 1, there's neither gain nor loss. So we can determine how much we need to increase by so we won't lose. We just need to do a little calculation, and we'll find the answer to be 1.111 continuously. Now, we're increasing by 12%, then decreasing by 10%. According to this graph, we can see that it's just enough to gain. In another example, let's consider a more complex event where the probabilities are not all 50%. How do we calculate? For instance, if I have a 75% chance to increase by 5% and a 25% chance to decrease by 10%. We go for an average, which means every 4 times we have 3 increases and 1 decrease. From this graph, we can also see that it's increasing. By calculation, we can also determine that the answer is greater than 1, so it's gain. Now you've learned it. You can know how to determine whether you'll gain or loss. If you have any questions, you can also leave them in the comments below. Bye.